This movie covers subtopic 7.3 Climate Change, Mitigation and Adaptation under the main topic of IB ESS Topic 7, Climate Change and Energy Production. The significant ideas for this section are: mitigation attempts to reduce the causes of climate change, and adaptation attempts to manage the impacts of climate change. You need to be able to discuss mitigation and adaptation strategies to deal with the impacts of climate change and to evaluate the effectiveness of international climate change talks. First, we will talk about mitigation strategies. Mitigation involves reduction and/or stabilization of greenhouse gas emissions and their removal from the atmosphere. Mitigation is an attempt to alleviate climate change. Mitigation strategies include stabilizing or reducing greenhouse gas emissions, removing carbon dioxide from the air, and geoengineering. First, I will discuss strategies to reduce greenhouse gases. Strategies include reduction of energy consumption, reduction of emissions of oxides of nitrogen and methane from agriculture, use of alternatives to fossil fuels, and geoengineering. A mitigation strategy that can stabilize or reduce greenhouse gases includes reducing energy waste and making more efficient products, like this energy efficient motor, in all industries. This diagram illustrates that technology can yield a higher output of electricity from the same input of heat, reducing energy waste and greenhouse gas emissions. Reduction of energy consumption can occur by a society adopting alternative values and lifestyles. Human activity can be altered through education, incentives, and penalties. We can reduce our use of energy. We can reduce the energy produced through the burning of fossil fuels. Some lifestyle changes might include installing energy-efficient light bulbs, using less private transport, walking and cycling more, remodeling or constructing more energy-efficient buildings. We can find alternatives to refrigerants. We can use less packaging material. Stop the video and study the various mitigation strategies illustrated here. Can you think of additional mitigation strategies that would reduce our energy needs and greenhouse gas emissions into the atmosphere, thus reducing the impact of climate change? We can reduce energy consumption through education, through bans and taxes and incentives. Eating less meat can mitigate the impact of climate change because there would be less deforestation and decreased use of resources in focusing on vegetable production, resulting in an overall decrease in methane, carbon dioxide, and nitrous oxide release to the atmosphere. Also, we would not be losing the energy to feeding animals. Remember the second law of thermodynamics. If we reduce the amounts of rice production, we can mitigate climate change. However, is it even possible to reduce wet rice paddy fields? Consider food production in lower economically developed countries. How would they sustain their populations? We can reduce the amount of fertilizers used in agriculture, thus reducing the amount of nitrogen utilized by soil microbes, causing release of nitrous oxide into the atmosphere. Societies can replace high greenhouse gas emission energy sources with low greenhouse gas emission energy sources, like the renewables wind, solar, and hydroelectric, or the non-renewable nuclear energy. Though remember, there is controversy around the use of nuclear energy due to potential for accidents and the difficulty in storing the radioactive waste. Alternative energy sources would reduce the burning of fossil fuels, which would reduce the impact of climate change. Mitigation strategies also include removing carbon dioxide from the air. This is achieved by protecting and enhancing carbon sinks through land management, using biomass as a fuel source, using carbon capture and storage, and enhancing carbon dioxide absorption by the oceans. Protecting and enhancing carbon sinks through land management. We need to stop deforestation and protect and enhance carbon sinks through land management. We can enhance carbon sinks through protection of forests with legislation and providing reserve and park status. In protecting and developing forest lands, more carbon dioxide can be taken up by photosynthesis, thus reducing the impact of climate change. RED is a global policy initiative that aims to address climate change threats by reducing emissions from deforestation and forest degradation in developing countries. RED. The United Nations reduction of emissions from deforestation and forest degradation aims to support the RED program. So RED, reducing emissions from deforestation and forest degradation, is an effort to value the carbon stored in forests as a way to create incentives for developing countries to protect their environment. Through this mechanism, developing countries that voluntarily decide to participate could qualify to receive results-based payments for their efforts to meet RED requirements. Launched in 2008, the UNRED program provides countries with reliable and effective technical assistance, capacity building, and policy advice to implement RED. The UNRED program deploys the support of 3 agencies: the Food and Agricultural Organization of the United Nations, the United Nations Development Program, and the United Nations Environmental Program. Biomass is a source of fuel and can remove carbon dioxide from the atmosphere. Take a moment to stop the video and look at the different sources of biomass that can be converted to energy. This type of energy is called biofuel because the energy from these fuels comes ultimately from photosynthesis. The use of biofuel is considered bioneutral, thus mitigating climate change. Biomass originates from plants that have removed CO2 from the atmosphere, as illustrated in this graph. If the same crop that is used for biofuel is planted the following year, the CO2 released from the combustion of ethanol would be recaptured by the growing plants, making this a carbon-neutral source of energy. So biomass energy is both renewable and carbon neutral. However, if forests are cut down in order to grow crops for biofuel, then the biofuel might not actually be carbon neutral. Additionally, biodiversity has been lost if forests have been cut down in favor of growing biofuel. And is it a good idea to be converting potential food-growing land into energy-growing land? Is it fair for those of us with economic privilege to demand fuel for our cars and planes, and in so doing cause less food to be grown for countries who need food? We should consider all the implications of using ethanol as biofuel. Additionally, mitigation can be achieved through controlling the release of greenhouse gases into the environment through filters, scrubbers, or catalytic converters. Of course, this will increase the cost of energy and products. And the greenhouse gases still need to be stored. Another mitigation strategy is to enhance carbon dioxide absorption by the oceans through either fertilization of oceans with nitrogen, phosphorus, or iron to encourage the biological pump, or increasing upwellings to release nutrients to the surface. Iron is one of the limiting factors in ocean productivity. Thus, the thought is that if you add iron to oceans, the ocean productivity will increase and CO2 will be removed from the atmosphere by the phytoplankton. So iron enhances ocean productivity. Carbon is then sequestered in the phytoplankton, and when the phytoplankton die, they sink to the ocean, thus securing the sequestration of carbon dioxide. The movement from the atmosphere to the ocean is called the biological pump. Can CO2 be removed from the atmosphere by stimulating the ocean with iron or other fertilizers, thus reducing climate change impacts? Geoengineering or climate engineering are large-scale intervention projects. These strategies are largely hypothetical or computer models, as they have not yet been implemented. Geoengineering projects are designed to tackle the effects of climate change directly, usually by removing CO2 from the air or limiting the amount of sunlight reaching the plant's surface. Although large-scale geoengineering is still at the concept stage, advocates claim that it may eventually become essential if the world wants to avoid the worst effects of climate change. Critics, by contrast, claim that geoengineering isn't realistic and may be a distraction from reducing emissions. This design that you see here is of the engineer Stephen Salter, and it's of an unmanned ship designed to generate clouds that reflect away sunlight from the Earth. Using high technology, it is possible to extract CO2 from the atmosphere and sequester or store it underground. Direct air capture is largely a theoretical technique in which CO2 and potentially other greenhouse gases are removed directly from the atmosphere. The current technique uses large fans that move ambient air through a filter, using a chemical absorbent to produce a pure CO2 stream that can be stored. Using high temperature and pressure, the stored CO2 can then be stored underground permanently, thus sequestering CO2 from the atmosphere and reducing the impacts of climate change. Here are some more geoengineering ideas. Send giant mirrors into orbit to reflect sun rays. Release reflective aerosols into the stratosphere to reflect sun's rays. Thin cirrus clouds, which have a net warming effect. Develop high albedo crops and buildings. Also, release microbubbles into the ocean to make it more reflective, like an ocean mirror, reflecting the sun's rays. And like I already mentioned, using ships to spray sea salt in order to make light reflecting clouds. Stop the video and look at these geoengineering strategies. Can you identify all of them? There is a new one here. Can you guess what it does? And how did you do? Notice that the new geoengineering strategy is the genetic modification of plants to make them have higher levels of photosynthesis. Even if mitigation strategies drastically reduce future emissions of greenhouse gases, past emissions will continue to have an effect for a long time. Now we are moving on from mitigation strategies to adaptation strategies. Adaptation strategies can be used to reduce adverse effects and maximize any positive effects of climate change. Examples include flood defenses, vaccination programs, desalination plants, planting of crops in previously unsuitable climates, and international efforts, including climate change talks. At least £1 billion a year are spent in Great Britain to manage rising sea levels to prevent coastal inundation. Here is an example of a flood defense that has been erected in Great Britain. Here are other examples of flood defenses. Flood defenses are an adaptation to manage rising sea levels and prevent coastal inundation. In this image, you see Japan's underground flood defenses and above ground flood defenses in the Netherlands and in California, USA. Vaccination against disease is an adaptation strategy to manage climate change that results in disease that may be shifting north due to changing temperatures, or may be a result of extreme weather events or water scarcity. In this image, you can see, in response to climate change, that there is a northward shift of mosquitoes carrying dengue fever. An adaptation strategy to prevent dengue fever is the use of mosquito nets. The desalinization of water is an adaptation strategy in response to climate change. As extreme weather events, floods, or droughts change water availability, desalinization will be necessary to reduce waterborne diseases and to ensure proper drinking water for societies. Treatment of water to prevent disease is also an adaptation strategy in response to the impacts of climate change. Pictured here are a straw filter, a ceramic filter, and a solar purification system. All adaptation strategies in the response to the impacts of climate change. We've discussed biome shifts that occur with climate change. As food-growing biomes shift north, we will be planting our crops further and further northward in areas that were previously unsuitable climates for growing. Stop the movie and read through these various adaptation strategies. You'll see a range in approach from vaccination programs to managing coral reefs in response to the impacts of climate change. Adaptation capacity varies from place to place. Regions with high NPP, like a forest, have higher adaptive capacity than regions with low NPP, like the desert biomes. Adaptive capacity varies from place to place and can be dependent on financial, technological resources. More economically developed countries, as shown here, can provide economical and technological support to lower economically developed countries, as shown here. There are international efforts and conferences to address mitigation and adaptation strategies for climate change, like the Intergovernmental Panel on Climate Change, National Adaptation Programs of Action, United Nations Framework Convention on Climate Change, and climate talks. The Intergovernmental Panel on Climate Change, the IPCC, was established in 1988 under the umbrella of the World Meteorological Organization, the WMO, and the United Nations Environmental Program, UNEP. The objective of the IPCC is to provide governments at all levels with scientific information that they can use to develop climate change policies. IPCC reports are also a key input into international climate change negotiations. IPCC reports cover the scientific, technical, and socioeconomical information relevant to understanding the scientific basis of risk and human-induced climate change, its potential impacts, and options for adaptation and mitigation. The United Nations Framework Convention on Climate Change, or UNFCCC, was initiated at the 1992 Rio Earth Summit with 154 signatories. The UNFCCC is the principal international treaty on climate change. The ultimate objective of the UNFCCC is to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. Members of the UNFCCC have met annually in conferences of the parties, or COP, in order to address progress in dealing with climate change. The UNFCCC initially set non-binding limits on greenhouse gas emissions for individual countries and contained no enforcement mechanisms. However, greenhouse gas data were collected, and the greenhouse gas data were used to create benchmark levels for the Kyoto Protocol in 1997 and for the commitment of those countries to greenhouse gas reductions. The Kyoto Protocol set binding levels of GHG emissions. The Kyoto Protocol was the first attempt to commit countries to reduce greenhouse gas emissions. It was a failure in large part because the United States, one of the largest emitters of greenhouse gases, refused to sign the legally binding agreement. Lower economically developed countries were not held to the same accountability as more economically developed countries, and this was a point of contention. Climate change since then has become politicized because countries have feared economic impacts from abiding by the restrictions. The Paris Agreement aimed at limiting global warming to less than 2 degrees Celsius and to pursue efforts to limit the rise to 1.5 degrees Celsius. Despite scientific evidence, climate change has become politicized. The President of the United States, Mr. Trump, has withdrawn from the Paris Accord. Rates of carbon emissions do show signs of slowing down. This reduction might be due to China moving away from coal. However, as CO2 emissions show in some parts of the world a slowing, look at what's happening in India. National Adaptation Programs of Action, or NAPAs. Plans by LEDCs are submitted to the UNFCCC describing the country's perception of its most urgent and immediate needs to adapt to climate change. Funds are available to finance the implementation of projects related to climate change adaptation. With NAPAs, LEDCs assess their country's vulnerability to climate change and extreme weather events. They then develop a prioritized list of adaptation projects that will help the country cope with the adverse effects of climate change. LEDCs that submit NAPAs to the UNFCCC then become eligible for funding. Are we ready for climate change? Societies will need to adopt both mitigation and adaptation strategies in managing climate change. To recap the contents of this movie, topic 7.3, climate change, mitigation and adaptation. Mitigation attempts to reduce the causes of climate change, and adaptation attempts to manage the impacts of climate change. Mitigation strategies include stabilizing or reducing greenhouse gas emissions through these different techniques, removing carbon dioxide from the air, also through these different techniques, and geoengineering. Adaptation strategies can be used to reduce adverse effects and maximize any positive effects of climate change. Examples of adaptations include these examples. This ends the movie for ESS Topic 7.3, Climate Change, Mitigation and Adaptation, under the main Topic 7 of Climate Change and Energy Productions. The slides are created by me, Dr. Nina Markham. Images are courtesy of Creative Commons unless otherwise indicated with a citation under the image. If all images on a slide are from the same source, the source is simply cited at the bottom of the slide. Additional insight was obtained from Mr. Dave Hoover's YouTube channel, also available resource for you. Another resource for you is your ESS textbook, whether in hardback form or online such as Cognity. Thank you for listening.